This video is on partial fractions. So let's say we had this fraction 3x plus 7 over x plus 1, x plus 3, where we have an algebraic term on the top, or it could also be a constant, and a factorized polynomial on the bottom. This can be written as a partial fraction with this bracket, x plus 1, under a, plus this bracket, x plus 3, under b, where a and b are constants that we need to find. So the question will be worded like this, where it says, given that this fraction is equal to this partial fraction, find the values of the constants a and b. So we have this equivalent symbol here with the 3 lines instead of the 2 for the equals, because for all values of x, these two sides are equal to each other with these two specific constants a and b. We need to find what these two constants are. So how do we find a and b? Well, the way that we do this is, firstly, we have to times everything in here by this denominator, x plus 1, x plus 3. So let's do that. So let's times everything by x plus 1, x plus 3. So when we times this by x plus 1, x plus 3, it just gets rid of the denominator. So this is equal to 3x plus 7. And this is equivalent to, and I'm going to go through this slowly and kind of step by step for the first one, but hopefully you should get the hang of this quite quickly. So we times everything by x plus 1, x plus 3. So it's going to be a over x plus 1 times x plus 1, x plus 3, and this is equal to, so this cancels out the denominator, and then this comes at the top with the a, so this is equal to a x plus 3 with the denominator going away, and for b over x plus 3 it's going to be b over x plus 3 times, and then the same thing, x plus 1, x plus 3. This cancels out the denominator, and then this comes to the top with the b, so this is going to be equal to b x plus 1. So therefore, if we times everything by x plus 1, x plus 3, this is going to become 3x plus 7 on this side, and this is equal to a x plus 3 plus b of x plus 1. Now, from here, there are two ways that you can do this to find the values of a and b. The first way that you can do it is by substitution. And the way that you do this is you sub in values for x, and the aim of doing this is you want to make one of these brackets equal to 0, and this is basically like solving a factorized quadratic. So let's start with this one. We want to make this equal to 0, so we want to make x plus 3 equal to 0, so therefore x needs to be equal to minus 3. So what we're going to do is we're going to let x equal minus 3, and we're going to sub this value in for all the x values, and what's going to happen is this is going to cancel out this constant here, because this is going to be equal to 0, and therefore this will allow us to find the value of this constant here. So we've let x equal to minus 3, and we sub in minus 3 everywhere. It's going to be 3 of minus 3 plus 7 is equal to a of minus 3 plus 3 plus b of minus 3 plus 1. This side here, 3 of minus 3 plus 7 is equal to minus 2. And then this here is equal to 0. So this is a times 0. So this whole thing cancels out. So therefore it's going to be b of minus 3 plus 1. Minus 3 plus 1 is minus 2. So it's going to be equal to minus 2b. And then divide everything by minus 2 to get b is equal to 1. So that's the value of b, and then to find the value of a, we just do the exact same thing for this bracket, where x plus 1 is equal to 0, so therefore x is equal to minus 1, so therefore let's x equal minus 1, sub in minus 1 everywhere, so it's going to be 3 of minus 1 plus 7 is equal to a of minus 1 plus 3 plus b of minus 1 plus 1, and then what you can do, this is going to be equal to 4, this is minus 1 plus 3, which is 2, so this is going to be equal to 2a, and this here is 0, so this whole thing is going to cancel out, so therefore a is going to equal 2. And this is the final answer, where a is equal to 2 and b is equal to 1. So therefore this fraction here can be written as the partial fractions x plus 1 under a, which is 2, plus x plus 3 under b, which is 1. Now, I've kind of gone through the long route here of kind of showing how it works, but in reality, you can actually do this very quickly with substitution. The second way that you can find a and b is by equating coefficients. So in order to do this, first of all, we have to expand these brackets here. So this is going to be 3x plus 7 is equivalent to, and then this expanded is ax plus 3a, and then this expanded is bx plus b. And I'm going to quickly rewrite this as 3x plus 7 is equivalent to ax plus bx plus 3a plus b. And I'm going to quickly factor out x from this to show what's going on. So 3x plus 7 is equivalent to a plus b of x plus 3a plus b. And then from here, what you can see is that the coefficients of x here is a plus b, and the coefficient of x here is 3. So therefore 3 has to equal a plus b, and likewise the constant term here is 7, and the constant terms here are 3a plus b. So therefore 7 has to equal 3a plus b, and we have a pair of simultaneous equations here which we can solve. I'm going to rewrite this as 7 is equal, I'm just going to do it with this one on the top, and then 3 is equal to a plus b, and I'm going to minus this whole thing here, so it becomes 4 is equal to 2a, and then the b cancels out, so therefore a is equal to 2, and then we can sub a back into here to get 3 is equal to 2 plus b, so therefore b is equal to 1. So a is equal to 2, b is equal to 1, so therefore if we write this as a partial fraction, it's going to be 2 over x plus 1 plus 1 over x plus 3. Now, as you can see, it gives out the exact same answer for the partial fraction. It's just two different ways of doing it. Now, personally, I prefer substitution. I think it's much easier to do and much quicker. The kind of the way that I've gone through it, I've kind of gone through it very full on to show exactly what's going on. But when you do this in exam, you can do substitution very quickly. But it's up to you, whichever one you prefer. So here's another example, this time with 3 brackets in the denominator, so therefore there's 3 terms in the answer, and they'll either give you 2 or 3 brackets in the denominator, never any more. But the approach is the exact same, it's just a bit more work at the end. So firstly, we're going to times everything by the denominator, so this is going to be 7x plus 17, and this is equivalent to, and then what we can do is times everything by the denominator, the x minus 1 cancels out and leaves with x plus 2 and x plus 3, so it's going to be a of x plus 2 x plus 3, and this is going to be plus, and then the x plus 2 is going to cancel out and leave with x minus 1 and x plus 3, so this is going to be equal to b of x minus 1 x plus 3, and then it's going to be plus c, and then the x plus 3 cancels out and leaves with x plus 2 and x minus 1, so it's going to be c of x minus 1 x plus 2. And then what we need to do now is sub in the values to cancel out. So firstly, we're going to do this bracket, so x plus 2 is equal to 0, so therefore it's going to be x is equal to minus 2. So let x equal minus 2, and then sub in minus 2 everywhere. So on this, it's going to be 7 of minus 2 plus 17, and this is equal to, so this here means that this is going to be 0, so this cancels out, and this here also has the x plus 2, so when you sub in minus 2, this is also going to cancel out, so therefore it's just going to be the b left, so it's going to be b of, and then sub in x as minus 2, it's going to be minus 2 minus 1 of minus 2 plus 3. Do the maths, so this here is going to be 3, and this is going to be equal to minus 2 minus 1 is minus 3, and then minus 2 plus 3 is 1, so it's going to be equal to minus 3 b, so therefore b is equal to minus 1. And then here we need to x plus 3 is equal to 0, so then x is equal to minus 3, so let x equal minus 3, and then sub in x is equal to minus 3, so it's going to be 7 of minus 3 plus 17 is equal to, and then this here is going to cancel out because we have the x plus 3 bracket, and this here is also going to cancel out because we have the x plus 3 bracket, so that's going to be equal to 0. So we just have c left, so it's going to be c, and then sub in minus 3, so it's going to be minus 3 minus 1 of minus 3 plus 2, and then we do the maths, this is going to be minus 4, and this is equal to, so minus 3 minus 1 is minus 4, and then minus 3 plus 2 is minus 1, so therefore this is going to be 4c if you times that together, so therefore c is going to be equal to minus 1. And then for the final bracket, we want x minus 1 to equal 0, so therefore we want x is equal to 1, so we let x equal to 1. So what we do is we sub 1 in here, so it's going to be 7 1 plus 17, and this is going to be equal to, and then this bracket here is going to equal 0, so this cancels out, and this also has the x minus 1, so this is going to cancel out as well. So we're just going to be left with a of 1 plus 2, 1 plus 3, and then what we do is this here is going to be 24, and this is going to be 3, this is going to be 4, and then 3 times 4 is 12, so it's going to be 12a. So therefore a is going to be equal to 2. So we have all the values now, so therefore what we do is we can rewrite this as 2 over x minus 1, because a is equal to 2, plus minus 1 over x plus 2, plus minus 1 over x plus 3. But a bit of a neater way to write this is x minus 1 under 2, and then we can just bring the minus here down here to do minus x plus 2 under 1, and then minus x plus 3 under 1, like this. And this is the final answer. Here's an example where we have a squared bracket in the denominator. So remember that when you have a squared bracket, this just means that there are 2 of this bracket. There are 2 x plus 1 brackets, and this is under 2x plus 1. So how do we do this? How can we split this into partial fractions? Well, logically, if we've seen so far, you might be tempted to say, okay, we can do x plus 1 under a, and then plus b over x plus 1, because we have the 2 brackets, we can split them into partial fractions. But the problem with this is, if we have this, these 2 fractions have the same denominator, to the point where, because they have the same denominator, we can just add them together to become a plus b over x plus 1. And hopefully you can appreciate that there is no way that this is going to be 2x plus 1 over x plus 1 squared. There is no way that this is going to be equal to this up here, because first of all, this has x plus 1 squared in the denominator, where this only has x plus 1, and this has an x in the numerator, but this is just going to be 2 constants, a and b, like this. But so therefore this is just going to be a normal number when it's not going to be an algebraic expression. So this doesn't work. There is no way in which you can separate this into this partial fraction. So what can we do instead? Well, we can split this up into partial fractions, but instead we do it like this, where we have a over x plus 1 plus b over x plus 1 squared. So do this for whenever you have a squared bracket in the denominator, and this works. We can find the values of a and b using the same method, but when you have a squared, this is called a repeated root. When you have this squared bracket, you do one of the partial fractions as x plus 1 and the other one as x plus 1 squared. So here's an example of a question like this, where we have this squared in the denominator, and we know that it's going to be split into this, and we need to find the values of the constants a, b, and c. So what we're going to do is we're going to times everything by this denominator here. So this is going to be equal to 8x plus a, and this is equivalent to, so firstly, with the a, the x minus 1 squared is going to completely cancel out this. So the only thing that's going to remain is this one bracket, the x plus 3. So this is going to be a of x plus 3 plus, and then this times by this. Well, one of these brackets will get rid of the x minus 1 denominator, but the other one will remain. So this is going to be b of x minus 1 x plus 3, because one of the brackets will be cancelled out but the other one will remain. And then for the x plus 3, the x, when you times everything by this denominator here, it's going to get rid of the x plus 3 in the denominator, but this squared bracket is still going to remain, so it's going to be c of x minus 1 squared. Okay, let's firstly focus on this bracket here. So this is going to be when x plus 3 is equal to 0, so this is going to be when x is equal to minus 3. So let's sub this in. So it's going to be 8 minus 3 plus 8 is equal to, and then this is going to go away because this is going to be equal to 0. Same with this bracket because it's got an x plus 3 bracket as well. So we're just left with c. So it's going to be c of minus 3 minus 1 squared. We can simplify this, so this is going to be minus 16, so this is going to be minus 24, and this is plus 8, and this is going to be equal to, so minus 3 minus 1 is minus 4, and then this squared is going to be 16, so it's going to be 16c, so therefore divide both sides by 16 to get c is equal to minus 1, and then we can let x equal to, and then we're going to do this bracket is equal to, so x minus 1 is equal to 0, so this is going to be equal to 1, and then we sub this in, so it's going to be 8, 1 plus 8 for this side is going to be equal to, and then this is going to be a of 1 plus 3, and then this is going to go away because this is going to be equal to 0, so then this bracket goes away, and then this here is going to go away as well because you've got the x minus 1 here as well, so we just got the a of 1 plus 3. Simplify this to get 16 is equal to, and then this is 4a, and then divide both sides by 4 to get a is equal to 4. So c is equal to minus 1 and a is equal to 4. So to find b, this is a tiny bit different because we can't just do the thing of subbing in 1 and minus 3 because this has both of these brackets. So no matter what we sub in, 1 or minus 3, this is always going to cancel out. So what we have to do is we have to do something slightly different, but it's very easy. Firstly, we know these constants already and we're going to sub them in. So this is 8x plus 8 is equivalent to, and then a is 4, so this is going to be 4 of x plus 3 plus b of x minus 1, x plus 3, and then c is minus 1, so it's plus c, so it's going to become minus x minus 1 squared. And then what we're going to do is just sub in any value of x. It literally doesn't matter what, and this is because we only have one term left, so whatever we sub in, we will only have b as the term left, and then we can just rearrange to find b. So I'm just going to let x equal 0 because I think this is the most simple kind of value you can give x. So this is going to be 8, 0 plus 8 is equal to 4 of 0 plus 3 plus b 0 minus 1, 0 plus 3 minus 0 minus 1 squared. Simplify this, this is just going to be 8, this is going to become 4 times 3, which is 12, and then this is going to be minus 1 and this is going to be 3, so this is going to be minus 3b, and then this is going to be minus 1 squared, so that's going to be 1, but remember we have the minus here, so it's minus 1 squared, and then it's minus that, so it's also going to be minus 1, and then we can simplify this to 8 is equal to 12 minus 1 is 11 minus 3b, move the 11 onto the other side to get minus 3 is equal to minus 3b, and divide both sides by minus 3 to get b is equal to 1. And that's the final answer, and then we can just sub this into here. So the partial fraction is going to be 4 over x minus 1 squared plus x minus 1 over 1 because b is equal to 1, and then it's minus 1, so it's going to be minus 1 over x plus 3. So that's the final answer. So here's another example where we have this repeated root of a square in the base. So for this, firstly times everything by the denominator to get 11x plus 5 is equivalent to, and then we times this denominator by this, and one of the x plus 1s cancels the denominator, but the other one remains, so this is going to be a of x plus 1, 2 minus x, plus b, and then both of the x plus 1's bracket is going to have to cancel out the denominator, just the 2 minus x remains, so it's going to be b of 2 minus x, plus c, and then the 2 minus x cancels out with the denominator, and the x plus 1 squared times is the c, so it's going to be c of x plus 1 squared, like this. So firstly, let's do this bracket here. So this is x plus 1, so x plus 1 is equal to 0, so it's going to be x is equal to minus 1. So let x equal minus 1, and then if we do that, it's going to be 11 of minus 1 plus 5 is equal to, so this is going to cancel out because this is going to be equal to 0, and this is also going to cancel out because this is equal to 0. So this is equal to b of 2 minus 1, and then we can sub in the value, so it's going to be this is going to be minus 6. 11 of minus 1 plus 5 is equal to, and then 2 minus minus 1 is 3, so it's going to be 3b. Divide both sides by 3 to get b is equal to minus 2, and then we're going to do this bracket here, so it's 2 minus x is equal to 0, so it's going to be x is equal to 2. So let x equal 2. This is going to cancel out, and this is also going to cancel out, just leaving the c. So it's going to be 11, 2 plus 5 on this side when we sub in the 2. And this is equal to c of 2 plus 1 squared. 11, 2 plus 5 is equal to 27. And this is equal to, so 2 plus 1 is 3, and 3 squared is going to be 9. So it's 9c, and divide both sides by 9 to get c is equal to 3. And then for the final substitution, this is the same thing as before, where because a has both the brackets, it doesn't it cancels out when we sub in -1 and 2, so therefore we have to sub in something else. First of all, let's sub in the values of b and c, which we've already got. So this is going to be 11x plus 5 is equivalent to, we don't know what a is yet, so this is just x plus 1, 2 minus x minus 2, because that's what b is equal to, of 2 minus x, and then plus 3 of x plus 1 squared, because c is equal to 3. And then what we can do is just sub in any value of x, doesn't matter what. I always kind of just do x is equal to 0, because I think this is easiest. So this is going to be 11, 0 plus 5 is equal to a of 0 plus 1, 2 minus 0, minus 2, 2 minus 0, plus 3 of 0 plus 1 squared. This here is just going to be 5, and this is going to be equal to 1 times 2, so this is going to be 2a, and then it's going to be minus, this here is just going to be 2, and it's going to be minus times minus 2, so it's going to be minus 4, and this here is 1, and then 1 squared is just 1, and then times 3 is going to be 3. Simplify this to 5 is equal to 2a minus 1, and then bring the minus 1 onto the other side to do 6 is equal to 2a, and therefore a is equal to 3. So a is equal to 3, and then finally we can write this thing out as x plus 1 under 3 minus, because it's minus 2, minus x plus 1 squared over 2 plus 2 minus x under 3. And this is how we write the partial fraction. Now, really quick, in the book, in 1.5 especially, they refer to combining partial fractions with algebraic division, and I don't really get why they do this, because with this you are algebraically dividing quadratics, which is specifically mentioned on the spec twice, both in the AS and the A-level section, of something that you won't need and won't be asked to do. So I'm just going to completely avoid this chapter, and I kind of advise that you avoid the questions where it asks you to divide by quadratics. So it's not too bad, but it's just something again that you're not going to be asked, so I don't know why you need to do it. I went through algebraic division in general of dividing by linear functions in the chapter 7 videos. So here's a question on partial fractions, so pause the video, have a go, and I'll go for the answers in about 5 seconds. Okay, so firstly what we do is we multiply the denominator by everything, so it's going to be 13 minus 4x, and this is equivalent to, so one of the 2x plus 1 is used to cancel out this, so it's just going to be a of one of the 2x plus 1s and then the x plus 3. For the b, both of the 2x plus 1 brackets are used to cancel out this, it's just going to be b of x plus 3, and then it's plus c, and then the x plus 3 cancels out the c, so it's just going to be 2x plus 1 squared here, and then we can do the substitution. So I'm going to start with 2x plus 1 is equal to 0, so therefore it's going to be x is equal to minus a half, so it's going to be 13 minus 4 of minus a half is equal to, and then this is going to cancel out and become 0 because it has this bracket, and this is going to cancel out as well, so it's just going to be b of minus a half plus 3. Minus 4 times minus a half is going to be 2, so this is going to be 13 plus 2, which is equal to 15, and this is equal to, and then a half, minus a half plus 3 is equal to 5 over 2b, so therefore b is equal to 15 divided by 5 over 2, which is equal to 6, and then we're going to do this bracket, so it's x plus 3 is equal to 0, so it's going to be x is equal to minus 3, so this is going to cancel out. Well, first of all, let's write this, so it's going to be 13 minus 4 of minus 3, and this is going to be equal to, so this bracket is going to cancel out because it has x plus 3, and this bracket is going to cancel out because it has x plus 3, but this one isn't, so it's going to be c of 2 of minus 3 plus 1 squared. 13, so minus 4 times minus 3 is 12, so 13 plus 12 is equal to 25, and this is equal to, so 2 of minus 3 is minus 6, and then plus 1 is going to be minus 5, so this is going to be 25c, and then 25 divided by 25 means that c is just equal to 1. And then for a, because it has both brackets in it, so it cancels out all the time, we have to sub in any value. So first let's sub in b and c, so this is going to be 13 minus 4x is equivalent to a of 2x plus 1 x plus 3 plus, and then b is 6, so this is going to be 6 of x plus 3, and then c is just 1, so this is going to be 2x plus 1 squared. And then what we do is sub in any value of x we like. I'm just going to do x is equal to 0, so this is going to be 13 minus 4 of 0 is equal to a of 2, 0 plus 1, 0 plus 3, plus 6 of 0 plus 3, plus 2, 0 plus 1 squared. And then we can simplify this. So this is just going to be 13, and this is equal to, so this is going to be 1 times 3, so this is going to be 3a, and then this is going to be 6 times 3, which is going to be 18, and this is going to be 1 squared, so this is going to be 1. And then we can simplify this to 13 is equal to 3a plus 19. Move the 19 onto the other side, so it's going to become minus 6 is equal to 3a, so therefore a is going to be equal to minus 6 divided by 3, which is equal to minus 2. So a is equal to minus 2, so we found the values of the constants a, b and c. A is equal to minus 2, b is equal to 6, c is equal to 1, and if we wanted to write it like this, it would be minus 2 over 2x plus 1 plus 6 over 2x plus 1 squared plus x plus 3 under 1. And that's the final answer.